Hello everyone. So this is again one lecture on superconductors where we will talk about some important properties of superconductors. First property, the current in the superconductor persists for a very long time. So this is demonstrated by placing a loop of the semiconductor in a magnetic field, lowering its temperature below Tc and then removing the field. व्हाट डू वी डू, एक लूप लेंगे सेमीकंडक्टर का जिसे हम लोग प्लेस करेंगे मैग्नेटिक फील्ड में एंड हम लोग उसका टेम्परेचर कम करेंगे बिलो क्रिटिकल टेम्परेचर और ट्रांजिशन टेम्परेचर व्हाट वी कॉल, और उसके बाद में फील्ड को रिमूव कर देंगे. देन there will be a current which is set up, and that current which is set up that persists for a very long period without any attenuation. Second property, superconductivity has normally been observed only for those metallic substances for which the number of valence electrons lies between 2 and 8. This property is self-explanatory. Third property is, in all cases involving transition metals, the variation of critical temperature with the number of valence electrons shows sharp maxima corresponding to Z equals to 3, 5 and 7. Fourth property is, when we consider a value of Z, for a given value of Z, certain crystal structures, they are more favorable than others. For example, when we talk about alpha manganese and beta tungsten structures, they are conductive to the phenomenon of superconductivity. Fifth property is, the magnetic field does not penetrate into the body of the superconductor, and this property we have already studied, and that is called as Meissner effect. And this Meissner effect, it is the fundamental characteristic of superconductivity, because जब हम लोग superconductivity define करते हैं तब हम लोग सिर्फ इतना नहीं बोलते कि it has zero resistance, because zero resistance metal जो होता है, that is also not necessarily a superconductor. So when we define superconductivity, we necessarily say that a material with zero resistance, and inside that particular metal the magnetic flux density will be zero, which is nothing but the Meissner effect. However, when the magnetic field is greater than a critical value, the superconductor becomes normal conductor and it has the largest value at T equals to 0. Superconductivity occurs in materials having high normal resistivities, and for this there is one condition, which is n into rho, it should be greater than 10 raised to 6. What is n? And it is the number of valence electrons per centimeter cube, and rho is the resistivity in electrostatic units at 20 degree Celsius. So suppose आपके पास कोई भी material है and for which n into rho greater than 10 raised to 6 है, so you can say that that is a condition for a material to be superconductive in nature. Seventh property is, when the current through the superconductor is increased beyond a critical value, the superconductor again becomes a normal conductor. So there is a restriction on the value of critical field, critical temperature, critical value of current. अगर उससे ज़्यादा करंट बढ़ाओगे या मैग्नेटिक फील्ड बढ़ाओगे या फिर टेम्परेचर बढ़ाओगे, then that superconductor becomes a normal conductor. So eighth property is, the specific material of the superconductor shows an abrupt change at T equals to Tc. Specific nahi, specific heat basically. So when you will check the specific heat of a material of the superconductor at transition temperature, suddenly the specific heat increases. Some of the general features of superconductors also we will see. Monovalent metals are not generally superconductors. Ferromagnetic and antiferromagnetic materials are not superconductors, and superconducting materials are not very good conductors at room temperature as the normal metals. Amorphous thin films of beryllium, bismuth and iron show superconductivity. Bismuth, antimony and tellurium became superconducting under high pressure. However, exceptions are there. So these are the general features of superconductivity which we have studied also, and which I have put in here. So thank you so much.